Talk today about chapter 12, section 5. We're kind of like in a part of the class, and you can probably tell from last class that we're kind of free to kind of wander wherever we want at this point, okay? I really want you to see this topic, and then next week I'm going to talk a little bit about sequences and series on Tuesday, and then we'll spend most of Thursday talking about the final. Which is, you know when the final is? Should be on your schedule.
It's in my book. I have it written down.
Should be on our schedule. So I just don't recall if it was on a Tuesday or a Thursday.
Hold on, let me look at it.
It'll say.
May the 12th on Thursday.
It says Thursday? Okay.
It's
I'll verify that next week.
12:30 to 3:15.
All right, so look at this problem. I've already had a comment that this problem is too easy if I'm asking you to put these two together, which is what I'm going to ask you to do to start. So how do we put these two together?
You can have a basic with a common denominator.
Okay. All right, that might be a little excessive to imply that there's going to be some sort of mating ritual occurring here, but we will get a common denominator, which would be what? I mean, like, what do I need on this one?
It's going to be
X minus 3 on the top and on the bottom, and then I do the same on this one, but X minus 2. This should not be news, right? This is something we've all done.
Yes.
All right, so
Explain that last step.
they're gonna make babies apparently.
Okay. That makes a lot more sense.
Okay, thank you. 3x minus 6. You all right?
Yeah.
Okay.
My life is a
Oh, okay.
Speak for yourself.
All right, so 2x minus 6 here over x minus 2 times x minus 3. So there is one little tricky part to this problem, I would say, and that's that minus sign in the middle. How that, 2 gets distributed, and then the minus has to get distributed, right? So what's the final result?
X over x minus 3 times x minus 2.
What is it? X over, just an x is left on top, that's it?
Yeah, just x on top and then x over 2. I'm x minus 2.
And on the bottom, I wouldn't have to do this, but I could multiply those together.
That'd be x squared minus 5x plus 2.
Easier for you to say you read and figure out.
No, I wasn't actually.
Is that all right?
All right.
Okay, so now we know how to do this. How about this, though? Let me take this back off here because that's where I started the problem. Is everyone with me?
So far.
Okay, because this is important. The question is not how to go from here to here. The question is how to go from here to here, backwards. Understand what I'm asking you?
Yeah.
If I were to give you this problem right here and ask you to separate it into two fractions,
I mean, we could factor the bottom.
you could factor, so let's look at the reverse process. You could factor the bottom, great, right? But how are you ever going to know that this x came from 3 minus 2x and 6, what? This turns into a minus plus over here?
Yeah.
6. How do you know that there was a 6 and a negative 6 and a 6 and it was 3x and 2x? I mean, it could have been what, 7x and 6x and then,
542.
whatever, infinite number of things you could think of, right?
If we
Do you
somehow
understand?
even knew that it was going to be something x plus or minus something.
Yeah. I mean, there's really, do you understand that this would, at this point, we're kind of hung up?
Yeah, for all we know, that could have been like a 0 on top of it or something.
Yep. Yeah. So this is not as clean and easy to go backwards as it is to go forward.
Right.
But it's an important process to be able to go from here to there. In fact, so important that we have a name for it. It's called partial fraction decomposition. All right? So going from here back that direction is called partial fraction decomposition. So that's what today is about. Partial fraction decomposition. And a lot of times in a pre-cal class, they start with something like this, almost to like immediately weed out the weak algebra students, like to just get them out of there. You know, not get them out, scare them, you know, shake them real quick, you know, and just be like, whoa, hold on, we're going to get into math like right away here. All right, so here's what we're going to do. When we have to understand what we're looking at before we can get a method for this. And then this is more of like a process that there's steps to it that you learn, kind of like when we were graphing functions, there's like a process. So here's where we'll start. First step, you need a rational expression to even begin this. Is this a rational expression? Yes? So I'm keeping this on the board because this is going to be our first example I do. We know what it needs to turn into in the end, right?
Right.
But first thing we do is look at it. Is it a rational expression? Sure, it's a polynomial divided by a polynomial, right? The second step will be kind of a check that we do. If the degree of numerator is less than degree of denominator, is that all right if I write it like that?
Yeah.
If the degree of the numerator is smaller than the degree of the denominator, move on to the next step. If not, in other words, I should write it so explicitly so you can see it. If the numerator's degree is bigger than or equal to the denominator's degree, you have to do long division first. Remember long division?
Yeah.
Okay. Do long division first. All right, so that's going to be our second step.
That's a long step.
Okay, the third step is where things really start to get long, all right? So what I'm going to do is, because it becomes such a long process, I'm going to say on part 3, identify factors. And do the partial fraction decomposition, which I'm going to now abbreviate from here on PFD, not PDF, PFD. So please understand that this step right here, I still have not shown you what that is yet. And I'm going to show you with some examples. And then at the end, I'll be able to summarize that in more of a method for you, okay? All right, so let's take this first example. We're going to say this is our first example. We need to try and break it up and take it back to where it came from. So first step, is it a rational expression? Yes, right? Is the degree of the numerator smaller than the denominator? What's the degree of the numerator? 1. The degree of the denominator? 2. So it is, right? So I move on, and I do the partial fraction decomposition. So here's what I'll do. I'm at step 3. Am I recording? I am. So here's what I know. I'm trying to break this thing down. And I'm going to look at this and say, can I factor the denominator?
Yes.
Yes. So try and factor the denominator right now. And this turns into x minus 2x minus 3. All right. Each of those factors that I'm looking at here are called linear factors because each one of... What's his name? Hey. If you're tired, seriously, you're not going to hurt my feelings if you don't attend? Okay. All right, so linear, this is a linear factor because x to the first power, right? This is a linear factor, x to the first power. We call these distinct linear factors. Let me just put a little arrow here. These are two distinct linear factors. Distinct meaning what? They're different from each other, right? Like if this was x minus 2 and x minus 2, then I wouldn't have written x minus 2 times x minus 2. I would have written x minus 2 squared, right? And in that case, we wouldn't call that a distinct linear factors. We call that a repeated linear factor, all right? So I've got two distinct linear factors. That's all I have, right? Two distinct linear factors.
Does it have to be broken down to the linear factors?
If it can be. Sometimes you can't. Sometimes what's down here is not linear and it's quadratic, and then we have a different thing we have to do. Yeah. Yep. So right now in this example, I have two distinct linear factors. So what I do is I say to myself, all right, well, if I've got two distinct linear factors, then I know that this must turn into two fractions because I have two distinct linear factors. The first fraction has to be a number over the first linear factor, and the other one has to be a different number over the other linear factor. Those numbers up here, I don't quite know what they are yet, all right? So I'm going to call them something, and I'm going to use the standard letters that we use in here, capital A and capital B. So we have to understand that when you have a rational expression and the degree of the numerator is smaller than the denominator, and you factor out the bottom, if you get distinct linear factors here, this side must come from a number over one of them, a different number over the other one, added together. If there were three distinct linear factors, I would use A over this, B over this, C over this. If I had four distinct linear factors, A, B, C, D. Yes?
What if one of them was like a quadratic?
Let's get to that. We're going to kind of baby steps through this. We'll start with linear factors, then we'll get to repeated linear factors, then we go to quadratic factors, then irreducible quadratic factors, then repeated quadratic factors.
Okay, so there's a lot of factors.
There's a lot of different things that can happen here. We start with the easy one, which is linear, okay? At the end of the day here, I want to know what?
What A and B are.
What A and B are, right? That's what I want to know. Okay, so how are we going to do this from here? Well, let's start working with this like an equation, all right? I'm just trying to find A and B. So just remember, this is what we're doing. We're trying to find A and B. If we can do that, we're done, right? All right, if we look at the left side and the right side, is there an LCD?
Yes.
What is it?
X minus 2,
X minus 2 times x minus the whole thing, right? So what I'd like for us to do is multiply the left side by the LCD and the right side by the LCD. The LCD is x minus 2 times x minus 3. What happens when I multiply this on this side? Everything cancels except an x. So all you have is on the left is x, yes? With me? On the right side, when you do your LCD, it has to distribute to each one of these, doesn't it? So what happens when you multiply this? I'll just do it this time. A over x minus 2. What happens when you multiply that times x minus 2 times x minus 3? Those cancel, right? And you're left with the a times the x minus 3. So that's what I get when I multiply this one times LCD. A times x minus 3. And then when I multiply this one by the LCD, what happens?
It'll be ax
So I'm going to say plus b times x minus what? 2. Do you all have any questions? You got to go do some jumping jacks or something. Go like do a sprint down the hall or something. Can you do cartwheels?
Yeah.
Okay.
I wish.
I can't do cartwheels either.
Just
Yeah, go. Just go outside, get some water, walk around.
I understand.
would
Okay.
we then just expand that?
Okay, so yeah, we're gonna work with this. We're gonna expand it, but I just want to make sure everyone's on the same page here because I'm not showing the work of like putting it in there. We're okay? All right. So let's try expanding this out. Let's multiply. The thing is, we have 3 variables in here, don't we? We have ax minus 3a plus bx minus 2 capital B. You all agree with that? Now I'm going to do something interesting. This is a critical step to the problem. I'm going to put my x terms next to each other. And I'm going to put my stuff that does not have x's over here next to it. So all I did was just rearranged. Is that okay with you?
Except for the fact
Is that all right? All right. Now, on the first 2 terms, what do these both have in common in terms of like greatest common factor? X. So you could pull the x out, couldn't you? So do you agree I could write the first 2 terms this way? I could, yes? I could factor the x out of the first 2? Is that the same as this?
yes.
Right? That's the same? I'm going to choose to write it this way, and you'll see why. So I'm going to write it a plus b, parentheses x. And then these 2 right here, I'm going to write these 2 in parentheses. And I'm going to put a plus here. Is that the same thing? If these are both negative and I add them, it's still both negative? That's all the same? No questions?
Hold on. That should be positive, right?
Where?
If you're going to take out that.
I didn't take anything out. It's really like a positive 1. So 1 would go back there and still keep them negative. I know you're sitting there going, well, why are you doing that? You know, like, why are you pulling out a positive 1? There's no need to. Just bear with me for a second, all right? All right. We know that A and B are going to turn out to be numbers, right? And if A and B are numbers, then this should be just some number in front of x, shouldn't it? And this right here should just be a number by itself with no x's. And that has to equal this side of the equation. So I'm going to look at the left side of this equation like this. 1x plus 0 equals, isn't that what the left side is? It's a 1 in front of x, and it's nothing next to it. That must equal a plus bx plus negative 3a minus 2b. Do you see where I'm about to go with this? No? Not yet? If these two sides of the equation have to be equal, then the thing sitting in front of x here must be identical to the thing sitting in front of x here. The coefficient, right? That's the number in front of x. If this is an equation, both sides are exactly the same, the coefficient of x here must equal the coefficient of x here. The number by itself must match the number by itself.
So AB must equal 1?
A plus b must equal 1, right? A plus b must equal 1, and negative 3a minus 2b must equal 0. That's 2 different statements, right? 2 different, what do we call those? 2 different, what did we say? We're saying a plus b must equal what? 1, and then the other thing we're saying is negative 3a minus 2b must equal what? 0, and what is this? That's a system of equations,
Son of a biscuit.
which is what we've been doing, right? if we can solve both of those equations simultaneously for A and B, we will have A and B, won't we? Now it's your option here, how you want to solve this.
Start with the top one first, I guess, and then we'll do it by substitution.
You can do substitution or elimination. So what do y'all think? You still like substitution the best? Okay, so everyone do that one on your own. You know what the answers should be. I think you know. Everyone going to solve that system on their own. I think I'll solve it on my own over here. Don't copy me. Don't cheat off me. Right? I did elimination.
That's what I did.
I multiplied the top row by 3, and that way I could get my A's to cancel, and then I worked out what B was.
Yeah.
You might get fractions when you're working with them. Your answers should be the same, though. Now, the important thing after you get your answers is that you go back and you write it out the correct way. Like A is on top of the right piece.
I see where I went wrong.
You got it?
Yeah.
Okay.
It's that stupid simple math thing.
Go back into the problem where we had written A over something plus B over something. Did we write x minus 3 and x minus 2 like this, or was it the other way around? It was the other way. You have to make sure you're careful when you write your answer, because if you had put 2 here and 3 here, right, then you got to get the appropriate A, right, -2 on top of this one. And is this wrong?
No, you're right. But I know the original problem was, how should I say, 3 over x minus 3 minus.
Yes. Okay, so let's do this. If I replace my A here with -2, and I replace my B here with 3, if I rearrange the order and put this one over there, then that minus in front can go in and become a negative. Got it? So that's it. That's the partial fraction decomposition.
And would that be any less correct than the other way? Like just doing it like that?
Oh, no, it's the same. Yeah, you could leave it like that. You could do this, which is the same thing. These are both equivalent, so. All right, so let me ask you something. If I just did that and my denominator had two distinct linear factors, and I turned out having a system of 2 equations, what do you think is going to happen if I have 3 distinct linear factors? I'm going to have a system of 3 equations and 3 unknowns. I'm going to have an A, B, and a C, right? So that's going to be a 3 by 3 system, which, if you have to solve by hand, might become an issue, right? This is why I was telling you in a calculus class. In a calculus class, we have to do partial fraction decomposition, and we don't go through any of the steps for it. Like, we don't go through and actually do all this stuff. We just say, oh yeah, that turns into this. And you're like, what? Partial fractions? Oh yeah. So how you get there really, that's why I showed you how to use your calculators. Because that step could be tedious.
So that way we don't have a $200 people weight. $200 people weight.
That's right. All right, you ready for another one? Of course you are. You love these already. I can see it.
It's actually kind of interesting how you can apply this system.
Okay, we'll still go little kind of baby steps here. Let's do x plus 2 over x cubed minus 2x squared plus x.
So we can factor out an x.
Okay, first, do you have a rational expression?
Yes, we do.
Okay, is the degree of the numerator smaller than the denominator? Yes. Okay, so you can proceed by now factoring the denominator. So when I factor the denominator, I see a GCF of x. I can pull an x out. I get x squared minus 2x plus 1. You know what? Let me ask you, would you like to see one with 3 distinct linear factors, or are you ready for the next level of... You want to see one with 3 distinct linears? Okay, then let me change the problem a little bit. Make this minus 3x right here. Everyone see the change? All right, so here, continue to factor the denominator, and you'll get, and I'm going to put it up above so I can work it out. I'll have x plus 2 over x times what? X plus 1, x minus 3. Now, it does not matter what order you put those in, okay? Does not matter. We should all get the same result. Now, this must be equal to, we identify 3 distinct linear factors. Do you see them? X is a linear factor, x plus 1 is a linear factor, x minus 3 is a linear factor. They are distinct. So that means that I know for sure this is going to turn into a over x plus b over x plus 1 plus c over x minus 3. Understand that step? Okay. What did I do last time at this point? GCF or no, LCD? I know what you meant. LCD both sides?
Yeah.
Okay, so what happens on the left side when you hit it with the LCD? Everything goes away except x plus 2. On the right side, now this one's going to be a little different because when you hit this one with the LCD, the only thing that goes away is the x. Do you want me to write the LCD down for you? Just to have it? It's everything, right? The bottom? So if I multiply this one times the LCD, the x's cancel, but everything else stays, doesn't it?
Yes.
So I'm going to have a, then, not over, because it was on the top, right? Times x plus 1 times x minus 3. Then plus b times x minus 3. So this time, the x plus 1 factor is the only one that goes away. And then finally, plus c times x plus 1. Are we good?
Yeah. Then we expand on.
Yeah, this part's going to kind of suck. Okay, you ready? And I'm going to put a little arrow in there right here at this point. This is a point at which we can do a shortcut, which I'll show you after we do the long way. Well, the long way doesn't always, the shortcut doesn't always work. So
basically the long way is more powerful.
it's kind of like, what was it? Long division versus synthetic. Yeah, it's kind of the same idea. So let's expand this all out. Yeah. It's life, right? Okay, so what I like to do when I expand this, I like to put these two together first. And just a quick mental computation with some canceling and stuff. I think I get x squared minus 2x minus 3. Right? And then I have to pass an a through all of these. Right? Because that a is sitting out here. So won't it be ax squared and then minus 2x times a. I'm going to write it 2ax. And finally, minus 3a. Okay, everyone okay with that? Do the same thing here. Put these two together. What are these two together? X squared minus 3x. Now pass a b through those. Plus bx squared minus 3bx. Plus, it's my last one. Cx squared plus cx. All right. Are we all good with this?
So that's not going to be the last one, put all the common factors on next one.
Yeah, let's put all the x squareds together. Let's put all the x's, clump them together. Let's put all the things that don't have any x's together. So I'm going to have, as far as x squareds, let me take a little time to identify them first, because you don't want to miss any. Here's an x squared. Here's an x squared. And here's an x squared, right? And this is really like positive a, right? Plus b plus c, right? Those are the coefficients on x squared?
Yeah.
A plus b plus c. So tell me if I'm pushing too fast for you on this. Is it acceptable to you for me to write that?
Yeah. You just kind of skip the step.
I skipped a step of actually moving them over and looking at them all next to each other. Let me try and do the same thing for my x terms. Now I'm gonna do something different with my x's. I'm gonna do little squiggly lines under my x's. There they are. There, right there, like that. Those are the only things that have x's in them. How are you going to deal with that? You see the negative 2a? Is that a little confusing? You have a negative 2a, you have a negative 3b, and you have a plus c, right? So watch the way I'm going to do this. I'm going to write negative 2a minus 3b plus c. I'm going to factor an x out of that, right? So if I put this x through here, here, and here, I get those three little squiggly underlines, right? But I can't just put this like this.
No, plus.
I'm just going to put a plus out there.
Because that's still all.
It's separated, right? Separate term.
Now we just have that one by itself.
And we got pretty damn lucky, yes. We got lucky here. This one is the only one that is a number. It doesn't have x, right? Minus 3a. There it is. Okay. And we continue. This left side of the equation is actually
Plus 0.
0x squared sitting in front, right? So that means that 0 is equal to this stuff right here. What's the number in front of x? 1 is all of this stuff in front of the x right here. And 2 is equal to negative 3a. I'm going to put that into a system of equations. I'm going to have 3 equations, 3 unknowns. A plus b plus c must be 0. That's my first equation. Next equation, negative 2a minus 3b plus c must be what? 1. And finally, this last one is actually going to give me a lot of information.
Yeah.
Is negative 3a is what?
Negative 2.
Negative 3a is 2. Now, I did tell you that when we have a system of 3 equations and 3 unknowns, you try and get that diagonal thing going, right? But I actually know what a is here, don't I?
Yeah, it's negative 2/3.
It's negative 2/3, right? I know this right away. A is negative 2/3. And if A is negative 2/3, I should be able to get the rest, right? But how many of you have your calculators? Yes? Okay. Did you get your hands on one?
Yes.
Good. Good. All right. I would like everyone with their calculators to do this system however you are comfortable doing it on your calculator. See if you can get the answers. Obviously, that's going to be negative 2/3. But just remember, this is really 0b and 0c here, right? So you're going to do that matrix thing? No go? Do you have your, no? Do you have anything else? That's it?
So in the first row, just do 1, 1, 1.
Your first row is 1, 1, 1, 0. I don't know if yours are going to do it. Let me see it real quick. I think it does, actually, but... Do you have access to another one, or is this your only one?
That's my only one right
Is
now.
your only one right now? Okay. Then you'd have to do it by hand.
Fun.
Yeah. Because I covered this like what? We went over this, what, 2 classes ago?
I know how to do matrix. I just
Yeah, it's
Okay.
actually on the recording how to set it up.
Yeah, it's all there. So I don't think so, man. No, you can't put a matrix into those. Let me see this one. Man, there might be, but I'm not familiar with it. Data? No. I don't think you can. Is this all you have access to also? Okay, so if all you have access to is that, give me a second, then what you would do is you let A be negative 2/3, right? And then go into the first equation, replace that with negative 2/3, move it to the other side. So it would be A plus B is positive 2/3. And then you replace this with negative 2/3 again, and then move it to the other side, and you have another equation. Now it's 2 and 2, and you can solve that by hand. It's uglier because there's going to be fractions, but okay. What was your question? You got something? Did you get the A was negative 2/3? That should be right then. You want it? Who has answers? Okay, we got a couple. Okay, let's see. That's pretty quick. Good. So we have what you're getting like negative 0.666. That's okay.
Yeah, I would do that too, except for the third one, I got something weird.
That's 512.
What about for B?
0.25.
0.25, which is a fourth. And what about for C?
It's 512.
5/12. Point what? 41666, which is 5/12.
That's why we like fractions.
That's why we like fractions. So that's it right there.
This saves time
Mhm.
and paperwork
That's right. Very, very useful.
and tedious mistakes.
Definitely saves you from that. Computer's not going to mess up its arithmetic.
Unless you put it in wrong.
Well, yes, but then that's not the computer's fault. That's a syntax error, or that's a user error. All right. Assuming you can get this, all right? Let's go and draw our final answer. Okay, our final answer, remember, was, well, it's those 3 fractions. It was A over something, B over something, C over something.
Right.
Was it A over X?
Yeah, it's A over X plus B over X plus 1, and then C is over X over 3.
X minus 3, right?
Minus 3.
Okay, so if A is the fraction negative 2/3, right, then you could write this. And this is totally acceptable to write, 2/3 negative right there. If B is a quarter, you put just 1/4 here. And then C, 5/12, you can just put it like that. Now, that's probably not the way the book's going to have it, but in a calculus class, that's okay, because what we'll do in a calculus class is this constant will actually come out, and we're going to do something to what's left. This constant will come out, we'll do something to what's left take that constant out, we'll do something that's left. But if you were insistent on not writing it that way, you could just pass the denominator through. So all I'm doing is rewriting this as like this over 1, this over 1, this over 1, and then flipping, 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 and passing the number through the bottom.
So which would you prefer? Does it matter?
I don't care. But again, like I said, in calculus class, you'll just take it to here and just pop those out. So like what I mean is like for this, in a calculus class, you'll write that actually as a 1/4 times 1 over x plus 1. And then you'll do something to that. Okay?
Right. It looks a lot less ugly.
But the thing is, you have to be able to go from that rational expression to the partial fraction decomposition before you can do the calculus later.
I can see why you write it that way, because you just assume that all
Mm-hmm.
looks nicer.
Okay, what do you think? Oh, would you like to see the shorter way on that one?
Yes, please.
Okay. Show you the shorter way. Now, like I said, the shortcut won't always work, but in a calculus class, again, it can save your butt when you're trying to find things quickly. So I want you to go to the line where I drew the arrow. It should have been x plus 2 equals a x plus 1 times x. I'm trying to go off of memory here. Just tell me if I'm wrong here.
Plus 2.
Well, hold on. I think I've got it. Just
No,
that's wrong.
B is actually minus 3 for A.
Oh, 3. It's a 3 here. That's all. Okay. Hey, thank you. So remember that line?
Yes.
Okay. So when we're sitting there and we're looking at this, we're like going, crap, man, this is going to turn into a 3 by 3 matrix. I'm either going to need my calculator, I'm going to do it by hand. It might suck. So what we do instead, as a shortcut, as an option, is to look at the things you're trying to solve for. Like I'm trying to figure out what A is, right? Is there a way to kill all this junk over here off without killing off this term right here? So what I'm asking is, if I let you control x, if I let you change x to any number you want, then can you kill this and this without killing this?
Move it over to the other side, maybe?
Nope, I'm allowing you to replace x with a number right now.
X is whatever.
Is there? X is 0. Very good. Okay, so look, if I let x be 0 right here, it's going to make this 0, and then this is all gone, isn't it?
Yeah.
If x is 0 here, this is all gone. But if x is 0 here, this does not go away, right? This is 1. This is going to be negative 3. So that's what this shortcut is. We're going to just kind of have a little bit of a God complex here. We're going to go let x be 0. That's, yeah. I don't know. I guess so. In my mind.
Yeah, when he prays, it's like, yes, Robert.
I'm just referring to the God complex. I shouldn't have tried to do a voiceover of God there. I apologize. All right, so let x be 0. That means on the entire equation, turn all your x's to zeros. All right? So what is this side going to be? 2 equals a times, now what happens? 0 in here, you get 1. 0 in here, you get negative 3. And then plus, and then we already know what happens here, right? 0 and 0. That's all gone.
Oh, even the B and the C?
Yeah, because it's all multiplication, right? 0 times who cares times who cares. It's all zeroed out, all zeroed out. And that just says that 2 is equal to negative 3a. And that means that a is negative 2/3.
And then you just put it all back in?
Nope, nope, nope. We've got a. Now, repeat the process, start over, do your little God complex, try and not kill this one off, and kill both of those off. What are you going to choose for x? No, 0 will kill these two off. Negative 1. Do y'all see it yet? Look, how can you kill this? Basically, what factor is missing from here that's in both of those?
Yeah.
These both have an x plus 1, don't they?
Right.
This one does not. So if you can make that x plus 1 go to 0, you killed off the two outside ones.
Then what about? Okay. Then you're making one of them multiple 0.
Yeah, do you see the strategy here? X is negative 1. Has the effect of killing off this, because that becomes negative 1 plus 1 is 0. Right here, negative 1 plus 1 is 0. The two ends are gone. I say two ends, I'm talking about the A1 and the C1 are gone. But over here, I don't have negative 1, do I? I mean, I don't get 0. What do I get?
Negative 2.
1, negative 1 plus 2.
So 1.
1 equals, and then the only thing left here is the middle piece, right? So B times x, what's x? Negative 1, and then times, what's negative 1 minus 3? Negative 4, which is, oh wow, look, that's 4b, and b is 1/4. Man, this is much cleaner, isn't it? Although if you're using your calculator, you might have been done already. No, because we still had to expand all that, didn't we?
Oh, yeah,
And
we
collect
still
all
had-
those
yeah,
terms?
we were-
Yeah,
we
no.
were still working on it.
I still think this is faster, don't you? All right, can you get C now? Can you kill off the A and B?
X equals positive 3.
X is 3. So you're just looking at the factor that is missing from the one you're looking for, but appears in both of the other ones. So x minus 3 appears, x minus 3. To kill x minus 3, you let x equal 3. Okay, what's the left side? 5, and these two are gone for sure, right? So C times 3 times 4. So 5 is 12C. So C is 5/12. I like it. I like the shortcut. I encourage you to use it.
Yeah, is this?
Yeah, so yeah, there are times when it won't work. You ready to move on to the next level? Okay. You don't have an option. I think it'll go naturally. I think the next natural procedure is for you to see one where it won't work, right?
But then you just plug it in your calculator.
No, we'll just have to do the long way, which is to do the system of equations.
And then plug it in your calculator.
And then you go, oh yes, yes. Okay.
I like that shortcut, that's kind of cool.
It is, and that's what we try and use in calculus. We do the shortcut when possible. It's very efficient.
So is there any way you can like quickly tell, like, just by looking at it, it's like, okay, that one's not gonna be able to do the whole.
Yeah, let's do this next one. You'll see it. I hope you'll see it.
Is it whenever we have like, is it gonna be like whenever we have x minus 2 squared or something like that?
Let's do this. Shoot. It might be too much. Okay, let's try this one. X plus 2 over, this is going to look very similar to the last problem, x cubed minus 2x squared plus x. This is the one that I had up initially and I asked you to change.
Oh, so it
Okay.
goes back and forth.
So we look at it, we say, yes, this is a rational expression. Degree of the numerator is less than the denominator, so I can continue. I factor the bottom. The bottom completely factored should give you x times x minus 1 times x minus 1. You should get that.
So then that's just x minus 1 squared.
Yes, y'all see that?
Then we're back to the first problem.
Yes? Okay. Which is x plus 2 over x times x minus 1 squared. So what we've been doing up to this point is we've been saying, hey, for every distinct linear factor, we do like a over it, right? B over the next one, C over the next one, right? This time we don't have distinct linear factors. We have well, one distinct linear factor, x, right? This is x to the first power, so that's different than x minus 1. So I can put, just like we would think, a over x. That much makes sense? But because the next one is repeated, that means squared, here's what you do. You do b over x minus 1 plus c over x minus 1 squared.
What?
Okay. That's what you do. Now let me explain why you do this. What you're doing is you're saying here's a linear factor, right? But it's being repeated. So I'm going to put that linear factor, a number over that linear factor not being repeated, and then a number over that linear factor being repeated. So if this was, let's say that this was to the 4th power. Let's just say for the sake of demonstration. I would do b over x minus 1, c over x minus 2, d over x minus 1 cubed,
And then, you keep going.
e over x minus 1 to the 4th. So you keep on doing factors coming up in power until you reach the highest power. Does that make sense?
It
Yeah.
makes sense, but why?
Because they're different systems.
It's
it builds on each other.
It's because if you were trying to, you know what? Let's not worry about. No, it's because it's almost like reverse engineering it. You're going from the other side back to this, and you realize that when you put these two back together, when you put all that back together, right? When you put it all, you're going to have powers in there that are lower than the highest power out here. Yeah. Yeah, can we just take it on faith for now? Okay, thank you. Thank you.
Because my teacher said so.
Yeah, unfortunately it's going to be one of those. It's too much. Look, I'm trying to get to some good stuff here, so I don't want to go off on a tangent. Really don't. All right.
So do the LCD?
LCD. Your LCD is
X,
this whole thing over here, right? It's always going to be this thing over here. So what's the left side going to be? Well, it's always going to be the numerator on the left side, isn't it? So x plus 2 again. X plus 2. And then on the right side, think about what's going to cancel. Be very careful here. What's going to cancel when you do this one times the LCD? Just the x. What are you still left with? X minus 1 squared and the a, right? So a, x minus 1 squared. Okay, carefully again, multiply the middle one by x times x minus 1 squared. What happens? You'll be left with b. The x is there, and only one of those canceled. Okay? And finally,
And you just left with X.
cx, right? So plus cx. Any questions? Okay, so I'm looking at it, I'm saying, look, I've got 3 equations or 3 variables. I'm going to wind up with a system of equations, but maybe I can do a shortcut.
No.
Why not?
Because if you put 0, it'll.
Or
If you
cancel
put
out
1,
one.
it'll get rid of 2 of them. So.
No, that's okay, though.
Well, that helps us help one of them anyway.
Can you get A? Can you figure out what A is? In other words, can you kill these 2 off
Yes.
and not kill this one off? Yes? What are you gonna do?
No, 1.
You want to kill these 2 off.
So 1.
If I put 1, I'm going to kill this off.
Yeah, you put 0.
I want to leave this one. I want to keep this one, preserve it. So x is 0 right there, and x is 0 right there. We'll kill those 2 off.
Yeah.
All right? So we say a little deeper, a little more into the. Okay, thank you. There you go. Let x be 0, and you get 2. 2 equals, okay, a times what? This is negative 1 squared, which is just going to be 1, right? Negative 1 squared is 1. So a is 2. So far, it's all good. I have no problems so far. All right, next one. Can we get b? Can you get B?
Not canceling out.
No.
You see the problem?
I see.
You cannot kill this one off unless you use 1. That's your only choice. But if you use 1, you're going to kill this one off. Right?
Good goods.
So do you all agree I can't get B? Can you get C?
Yes.
Yeah.
Okay, get C. At least get C. Let's go. Let's do that much work.
1.
Let X be what?
1.
1. And it turns into what? 3 equals dead, and C times 1?
C.
So C. I've got 2 of the 3 variables I need, right?
But then could you just plug in those variables?
Yeah, so now we get into this position where we're like, look, we can't get B, but do we really want to go through the whole process of setting up the system of equations and doing all of it if we already know 2 of the answers, right?
No, just plug it back in.
Okay, so you can plug it back in, right? You can plug in, like you know what A is, right? You know what C is. So watch, I'm going to write X plus 2 equals A, which was 2, times X minus 1 squared plus B X times X minus 1 plus C, which was 3X. So do you all agree that that is me replacing C and A with what I know they are? Okay, but all we want is B. So at this point, God complex one more time, but don't try and kill anything off. Let's just plug a number in, and that should just leave us with a B, right? If I let all the x's be numbers, then we should just have B in there. So let's pick a nice number, not something that's going to kill stuff off. So x is 2, all right? Let x be 2. Let x, thank you. If x is 2, what do we get here? 4 equals 2 minus 1. That's nice. 2 minus 1? 1. Square it. 1 times 2. So we get 2 there. Plus, now be a little careful here, b times 2 times 2 minus 1 is 1. So 2 times 1. And then finally the last one plus 3 times 2, which is 6. So 4 equals 2 plus 2b plus 6. Move all your numbers to the other side.
2b equals -4.
2b is -4. And that means b is -2. So that was a little different version of the shortcut, wasn't it? I mean, I could use a shortcut to get 2 of the answers, but not
Are you always going to be
all
able
of
to at least get 1 or 2?
1 or 2 won't
You
help.
should be able to get 1 or 2, but it may not be enough. See, because if we still had 2 that we didn't know here, we wouldn't have been able to do what we just did
I
easily.
would assume that there's a pretty simple way for there to be 2 that we can solve for.
Yeah.
And then back to the A over X plus B over X minus 1 and all that?
Hmm?
Like for the final-
Yeah, now you'd write it A over X, yes. It was 2 over X, right? Bye. Have a good day. 2 over X, -2 over X minus 1, plus 3 over X minus 1 squared. Right, if you write out the original? Okay. I'd like to give you one to see if you can at least get it going, all right? See how you do with this. I'm curious to see if you understand this. Let's try this. X cubed minus 8 over x squared times x minus 1 cubed.
We have to do that long division.
You do not need long division. I'll give you that much. Because if you, remember, this is really like an x cubed, right? If you were to multiply all that out, that'd be x cubed, then bring it with an x squared, it'd be x to the 5th. And that's still going to be bigger, so don't need.